This video is going to look at the standard unit vectors, and all that we're talking about for a standard unit vector is we're going to use the letter I, and this is a bold I representing our vector, and I is going to represent the horizontal vector, which is 1, 0. And that means if we were to look at that vector on our axis here, then that means we're going to go 1 unit in the x direction horizontally. So this letter I, and again, when you see this, it's going to be a bold I, and for now on, you're just going to see me actually just write the letter I, and we're going to know that's going to represent this vector, which is 1, 0. And then we have the vertical component, which is j, and again, that would be a bold j to represent a vector of 0, 1, which means we have a vector that's going to go 1 unit in the vertical direction. So when we see the letter I, it's going to represent this vector 1, 0, and the letter J is representing the vector 0, 1, which is going to give us the horizontal and vertical component. Okay, and what that really means is if I was to write, for example, 2I plus 3J, then what that really means is that we would have 2 multiplied by I, where I is representing the vector 1, 0. So that's 2 times 1, 0, plus 3 times j, which is 0, 1. And if we multiply this out, we're going to get 2 times 1, which would be 2, and then 2 times 0, which is 0, and then 3 times 0, which is 0, and 3 times 1, which is 3. So if you notice, when we take this 2 and we multiply by the vector, the only thing that's going to change is the x coordinate, because this 1, 0 is our I component, because the other part, the y part of it, is going to go to 0. So all we're doing is taking the horizontal part, the 1, and multiplying that by 2, so we get the new vector 2, 0. And kind of the same thing when we multiply 3 times 0, 1. J is the vertical, so we're increasing only the vertical part by multiplying the 1 by the 3. So therefore we get 0, 3. So then we simply add the two vectors together, and we would get 2 plus 0, and then 0 plus 3. So we end up with the vector 2, 3. And you'll notice from above, 2i plus 3j, that's what that stands for. So we looked at the component form of 2, 3, then this 2i plus 3j is the what they call the linear combination. 2i plus 3j is just another way to write this same vector, but we're using this linear combination with this instead of the brackets with the component form. So when we see 2 comma 3, that's the same vector as 2, whoops, write this as 2i plus 3j. So these are representing the exact same vector. So for an example, if I was to give you the following linear combination, if I was to write negative 7i plus 10j, then that would be equal to negative 7. The I is representing the horizontal, j is representing the vertical, so then that would be a positive 10. So this is just two different ways of writing this particular vector. You can think of it as the same thing as we could write the fraction 1/2 as 1 over 2, or we could certainly write that as simply as a decimal as 0.5. Both of these represent 1/2, and over here we have the same thing where both of these are representing the exact same vector. So let's look at some operations, and it's going to be very similar to what we did with the component form here before. But if we were given, for example, a vector u is equal to 4i minus 3j, and we have another vector v which is equal to I plus 5j, and we want to find u plus v. So we simply want to add these two vectors together. So we can just bring down the first vector, which is 4i minus 3j, and we're going to add that to the other vector, which is I plus 5j. And then because we're adding, we really don't need the parentheses, so we could really think of this as 4i minus 3j plus I plus 5j. And at this point, there's two ways you can think of this. I mean, we can think of just simply adding your horizontal components and your vertical components. In other words, add your i's together and your j's. And we can kind of think of this almost similar to combining your like terms. We're going to take the 4i plus 1i, which would certainly just be 5i, and a negative 3j plus 5j, which would be 2j. So here we have the vector in this linear combination of 5i plus 2j. Now, once again, I just want to stress that this is the same thing as if we were to write 5 comma 2. We know that the I represents the X or the horizontal, J represents the Y or the vertical, just like 5 comma 2 represents the horizontal and vertical part of our vector. So in other words, let's look at this another way. We have the vector here u. We could actually write this the same thing as writing u is equal to 4 comma negative 3. And we could say v is equal to 1 comma 5. And then if we were to add these two vectors together, we would have 4 plus 1, which is 5, negative 3 plus 5, which would be 2, and realize we come up with the exact same answer as we did before. So once again, this is just another way to write our vectors in this linear combination format. All right, let's look at what happens if we were to take the same vectors, u and v. Let me bring those down for us. If we have the same vector, u is equal to, let's say, 4i minus 3j, and v is equal to 1i plus 5j. But now we want to look at what is u minus v. We would just subtract. Now we got to be careful now because we're subtracting, but we could write this as simply 4i minus 3j minus 1i plus 5j. And if we're subtracting now, we have to be careful with the negative and distribute the negative. So that would be negative I minus 5j. And then once again, we're basically going to combine our like terms. 4i minus 1i, that would be equal to 3i. And then negative 3i minus 5, I'm sorry, negative 3j minus 5j would be a negative 8j. So there we have our vector. And let's say that we were given a problem and we wanted to find, let's say, 2u plus 3v. Well, that means we would have to take 2 and multiply that by u, which is 4i minus 3j, plus 3 times v, which is 1i plus 5j. And the first thing is we would get rid of the parentheses by distributing the 2 and also distributing the 3. So we would end up with 8i minus 6j plus 3i plus 15j. And then once again at this point we would simply combine our likes terms. So we'd have 8i plus 3i, which would be 11i. And then we would have a negative 6 plus 15, which would be a positive 9j. So really, when we think of this linear combination in terms of I and j, you're almost going to treat it like you would if you had variables x and y when it comes to combining your like terms. All right, one last topic for this video is we want to still look at how can we change our vector if we're given, and we did this before, and it's going to be really the same process, where we're given the initial point of our vector and we're given the terminal point of our vector, and we want to put it in component form, or we really want to write it in that linear combination. So if we have the initial point, let's say of -2, 1, and the terminal point is 3, -2. And if we want to write this into a linear combination in standard form, and what that means is we want to move this vector so that it's going to start at the origin, we're going to go through the same process that we did before. We're simply going to take and the terminal point and subtract away the initial. So that means we would take 3 minus a -2, and that's going to give us the 3 minus a -2, so that would be a +5, and that would be 5i. And then we would take -2 minus 1, and that's going to give us a -3, and that would be the vertical component, so that would be 3j. So therefore we end up with 5i minus 3j. And once again, that's the same thing we did before when we were looking at the component form of 5 comma -3, but here we're just doing the same thing, but we're putting it in terms of I and j.